The last thing we're going to talk about with functions is how can we construct new functions. So construct new functions. I mean, what we've been doing is kind of building on the previous idea. So we started with polynomials, we built from that and got rationals, we built from that and got algebraic functions. So now we're saying if we know different functions, can we build another one? We can, and there are a couple different ways we can do it. One is sum. So what is the sum of two functions? It's kind of the same thing as the sum of two numbers. It's adding them up. So if I have two functions, f and g, the sum f plus g of x is just taking f of x and adding to it g of x. So that's one way that we could construct a new function, is we could add them together. Another thing I can do is the difference. If I know two functions and I want to build another function, I can do the difference. F minus g of x, this is just f of x minus g of x. Another thing I could do is I could do a product. So if I know two functions and I'm trying to build another function, I could do f times g of x, which is just f of x times g of x. Next, I could look at the difference. So what is the difference? The difference, sorry, not difference, quotient. I already did difference. So what is the quotient? F over g of x, which is f of x divided by g of x. Another thing I could do is take a linear combination. So what is a linear combination? Well, the word linear means a line. For us, that's going to mean you can't square anything. You can only take single powers of f and g. So a linear combination could be something like some constant a1 times f of x plus some other constant a2 times g of x. So all we're doing is taking a number, a1 and a2, those are real numbers. We're putting those in front of our f and g, and we're adding them together. So this is a linear combination. And we'll do an example of this in just a second. Last thing we're going to look at is the composition. So the composition is f of g of x. So we use this little circle to denote the composition. And this is f of g of x. So what you're going to do is replace x with g of x in f. That's what this means. So this means plug in g of x into your function f. And we'll definitely do some examples of this. So let's let f of x be the square root of 1 minus x. And let's let g of x be x cubed plus 1. And let's construct some different functions. So let's construct as many functions as we can think of. One type of function I could do is the sum. I could say that f plus g of x, that was f of x plus g of x, so add them together. Square root of 1 minus x plus x cubed plus 1. So that's one new function I could build using those two. What's another one that I could do? I could do the difference. I could do f minus g of x. Now here we want to be careful with parentheses. So f minus g of x, that was f of x minus g of x. So it's f of x minus, and I'm going to use some parentheses here, f of x minus g of x. If I distribute that negative, I'll have the square root of 1 minus x cubed minus 1. So there's a new function. I could have the difference. What else could I do? I could build a new function by the product. So what is the product? That would be f times g of x, which just means I multiply the two. So I'll have the square root of 1 minus x times x cubed plus 1. And again, I'm being careful with those parentheses. I want to make sure and multiply this radical by both the x cubed and the 1. I also have the difference. Keep doing that, the quotient. So what is the quotient? That would be f over g of x. So here I just divide the two. This is the square root of 1 minus x over x cubed plus 1. And don't forget here, I could find the domain by setting the denominator equal to 0, marking it out on the number line. So we already know how to find the domain of that. What else could I do? I could do the linear combination. So there are tons of linear combinations. In fact, infinitely many. One linear combination might be, how about 2 times the square root of 1 minus x plus 3 times x cubed plus 1. That's a new function. So I took numbers 2 and 3, multiplied by f, multiplied by g. How about another linear combination? How about 4 times f, so 4 times the square root of 1 minus x, plus 1/2 x cubed plus 1. That's another linear combination. You can see how many linear combinations we're going to be able to do. There are infinitely many of them. It just means put coefficients in front of your functions and then add them together. So tons of linear combinations. Lastly, let's try to build some functions using composition. Well, there are two compositions. I could look at f of g of x, which we defined as f of g of x. What this means is in my function f, so let me remind you what that was. F of x was the square root of 1 minus x. This means that instead of plugging in an x, because x really here is a placeholder, this just says subtract x from 1, then take the square root. So instead of plugging in x into f, I'm going to plug in g. So this is the square root of 1 minus g of x. Well, what was g of x? G of x was the x cubed plus 1. So this is square root of 1 minus x cubed plus 1. And remember, I want to be careful with my parentheses. I want to subtract off all of g of x. Well, if I do this, I'll get 1 minus x cubed minus 1. Well, these 1s are going to cancel, so I get the square root of negative x cubed. So there's one composition. I could also do g of f of x. Make a new function using this. Well, what is that? That's going to be g of f of x. Remind you that the function g, that was x cubed plus 1. So if I'm plugging in f of x, that means everywhere I see an x up here, I'll plug in f of x. So this will be f of x cubed plus 1. Well, what was f of x? That was the square root 1 minus x cubed plus 1. Is it possible for us to write this a little bit nicer? I think so. Whenever I'm taking the square root, that's the same as taking the power of 1/2. So this is really 1 minus x to the 1/2. So again, the square root is anything to the 1/2 power. The cube root is anything to the 1/3 power. Fourth root to the 1/4 power. You can see how this goes. And then when I have a power to a power, I just multiply. So this is 1 minus x to the 3/2 plus 1. So those are my two compositions that I could do. So the idea behind this all is taking functions that we already know, building new ones. So those are just some of the functions we could build. We could build infinitely many, but you can see how this is all working.